You know, we spend so much time talking about the cloud and AI, as if they're these invisible magical forces just floating around in the ether. But the reality? Well, it's heavily grounded in concrete, steel, and a staggering amount of electricity. Welcome to The Explainer. Today, we're going to look at the massive physical infrastructure required to actually keep our digital world running. And more importantly, we'll see how developers are solving the immense complexity of getting these facilities built. We're going to keep this simple and easy to follow, cutting right through the industry jargon to understand the real-world mechanics of data center construction.
Okay, let's dive right into this. Here's our roadmap for today. First, the massive power problem. Second, navigating construction complexity. Third, questions before you build. And finally, a gigawatt-scale solution.
Section 1. The massive power problem. The immense energy drain of data centers.
So, to really wrap our heads around this challenge, we have to look at the massive global scale of the issue, 11%. According to projections by Bloomberg NEF, by the year 2035, data centers could eat up between 2.2 and 6.2% of all global electricity. But in the US alone, that estimate shoots up to a potential 11% of the country's entire power grid. Think about that for a second. There's literally no other industry in the world that consumes power quite like this. The challenge isn't just about putting up walls and racks of servers anymore. It's about figuring out how to deliver highly reliable, immensely scalable power at lightning speed without completely blowing the budget.
And this brilliantly illustrates a massive paradigm shift. As Fabrizio Sousa, a global president over at Worley, points out, today's facilities just aren't simple builds. They aren't your typical big warehouses with some extra air conditioning. No, they're first-of-a-kind industrial-scale developments. We're talking power demands that rival entire small cities. They need behind-the-meter generation, advanced co-located power, water recycling, even desalination in some cases. It's fundamentally reshaping how we build infrastructure.
Section 2. Navigating construction complexity. The risks of building at scale.
Okay, so now that we've seen the massive energy footprint, let's look at the specific hurdles developers face when they try to build these things as fast as humanly possible. If we strip away all the corporate jargon, the literal roadblocks to keeping the power on are pretty severe. First off, you've got grid interconnection delays, which can easily push your project back by years. Add to that stretched global supply chains and the immense pressure of maintaining a mandated 99.99% reliability. I mean, you simply cannot have the cloud go dark, right? On top of all that, developers are walking into incredibly complex regulatory and local environments that constantly change depending on where they build. And finally, you absolutely have to hit mandatory ESG and sustainability metrics just to satisfy the financiers backing these multi-billion-dollar projects.
This quote from Girish Nair really hits the nail on the head. Solving these issues isn't just about basic engineering anymore. It's a deeply strategic puzzle. Accelerating what the industry calls speed to market, which is really just getting the data center built and generating revenue as quickly as possible, takes a massive amount of cross-industry expertise and long-term lifecycle planning.
Section 3. Questions before you build. Strategic planning for the future.
So how do you actually plan for something this huge? Well, before you even break ground, it starts with one massive question. How do you future-proof your asset in an evolving technology landscape? AI demand is just incredibly volatile and uncertain right now. Bridging the gap between knowing how complex these builds are and actually planning a facility that will still be relevant in 10 years, that is the ultimate puzzle. So, the crucial point is, to solve that puzzle, developers have to answer a gauntlet of strategic questions. How does your power and cooling actually align with your chosen location? How do you secure and critically decarbonize that infrastructure over its entire lifespan? What delivery model gives you the best balance of speed, cost, and risk? And how are you going to navigate local regulations and prove to the community that you're being responsible with water and energy? Success today absolutely requires answering these questions to keep both financial backers and local communities happy.
Section 4. A gigawatt-scale solution. Case study on a Texas AI data center.
Now, what's really interesting is when we move from macro theory down to a real-world application. Just look at the sheer jaw-dropping scale of this project. Worley recently did the early engineering for an AI training campus down in Texas. At full scale, it will feature 5 gigawatts. Actually, let's put that into perspective. That's 5,000 megawatts of gas power generation, paired with up to 1,250 megawatts of solar. The footprint? 20 separate buildings totaling 10 million square feet of space. It's essentially a massive gigawatt-scale microgrid, complete with high-voltage substations, transmission lines, and utility-scale battery storage, all built to hit a 99.95% availability target. It's literally a sprawling industrial complex dedicated entirely to training AI.
So how does this tie into getting it built fast? Well, when you're building something this enormous, air permits can drag you down for years. To avoid that delay, their strategy is to start with simple cycle natural gas generators. These are quicker to install and meet current regional requirements. Then, later on, they'll upgrade and seamlessly fold in more complex combined cycle units. It's honestly a brilliant way to achieve that crucial speed to market without giving up on the massive sustainable end goal.
So as demand for data centers continues its explosive growth to fuel our digital future, we have to ask, how will we balance all of this? How do we balance speed and scale with sustainability and resilience? It's a delicate act that requires partners who truly understand the full, complex spectrum of infrastructure delivery. I really hope this explainer helped demystify exactly what it takes to build the backbone of the internet. Thanks so much for joining me, and keep questioning the world behind the screen.